So today what I want to do is show you how to wire any mic to any radio. But first, let me clip this red wire. So I have to confess, I've been putting off doing this video for quite a while because this is kind of a tricky subject. It's complicated. There's a lot to talk about. This video is going to be one of my longer videos because I can't just do part of this explanation on how to wire microphones and not give you the whole story, because you can get into trouble if I don't. So I'm going to make this a one-shot deal and try and cover everything that I can on wiring microphones, and not just to ham radios, but also to CB radios too, because that's really what I started with, is wiring vintage CB radio microphones to vintage CB radios. Of course, back when I did that, they weren't vintage, but I'm just dating myself. So anyway, the course of this video, of course, is for the person that wants to wire a vintage CB microphone that they might pick up at a ham fest or off of Craigslist or Facebook Marketplace or something along those lines, to a modern ham radio such as the Yaesu FT710 or Yaesu FT891 or similar. So the big important thing to remember is most modern ham rigs have power on the microphone connector. So they will supply what's called phantom voltage to one pin on this connector. And most of them are this way. And the reason they're doing it is so that they can power up an electret condenser microphone in some of the ham-specific desk mics that are out there. So this Yaesu, for instance, on pin 3 of this connector has 5 volts. If you accidentally short that 5 volt voltage to ground or to another pin in the connector, potentially you could do some harm to the radio. Typically they have buffering inside of these things, so if it's shorted directly to ground, whatever chip in the radio is supplying voltage will just shut down to save itself. But I don't want to trust that chip to do its job. So therefore, I'm going to take extra precautions to not allow that to happen. When you're doing this, the very first thing that you want to do is identify which pin is supplying voltage. And then you want to isolate that wire so that you can never touch it to another pin unless you're using it. And the reason I mention that is because one of these microphones does use that phantom voltage to power up an electric condenser microphone. For the average person that's just wiring a vintage microphone to a modern ham rig, you don't have to worry about that. You don't need that voltage. It's going to have a battery in the bottom, and that battery is what's going to power up your microphone. So let's start where I started, and that's with CB radios. So CB radios are typically easy because you're only dealing with either 4 or 5 pins in most cases. Some of the newer ones will have channel up and down that you'll have to contend with. But just like with the power supply, you just identify those wires and you don't use them. So with let's say with a vintage 4-pin microphone, not this radio is a 5-pin, but with a vintage 4-pin microphone, you're going to have 4 circuits to deal with in the mic. You're going to have a common wire, which is sort of your ground. Then you're going to have a transmit pin, a receive pin. You're going to have a microphone audio wire. So those 4 pins: common, transmit, receive, mic. And typically on those 4-pin radios or 4-pin mics, the common wire is going to be stranded. So you can see right here that is a stranded, uninsulated wire. That's typically your common on a 4-pin mic. But it also does double duty in that when you combine this with the transmit pin, which is usually a red wire, it will key the radio up. So if I were to plug this into this radio, in fact, let's go ahead and try that. Let's see what happens. I'm going to take the shield and I'm going to take the red wire. I'm just going to touch them together, and we're going to see if this radio will transmit. Look for that red light to come on. So yes, that is the correct wire. So this red wire on this microphone plug is wired to the transmit pin, which allows it to transmit. Now on this radio, the transmit pin is these two pins down here, and if I touch them, once again, you'll see the radio transmit. Now there's no antenna to this, so I'm not going to hold it and transmit very long, but it does work. So 4 wires. We have common, we have the transmit wire. In this case, that leaves the black wire for receive, because most of these radios, you have to connect 2 of these pins together for the receive function in the radio to work. And then that leftover wire, and this one, it's a white wire, this will be our microphone audio. So this is what comes out of the actual amplifier board in the microphone. And that's it. So these older 4 pins are pretty easy to wire. You just have to figure out what pins in the radio are doing what. In this case, it's transmit, common, receive, and then if it was a 4-pin radio, of course, the last one would just be mic audio. But this is a 5-pin. Now, what's the difference between a 4-pin and a 5-pin CB mic plug? Well, the difference is actually inside the radio. What they've done, like on this Kerber 142 chassis, is they separated the common wire and the microphone shield, made that 2 discrete circuits. So the common wire will allow you to transmit and receive, but it doesn't have anything to do with the microphone audio. And then the shield is just strictly for the audio circuit. It has nothing to do with the common or the transmitter receive functions. So on those, you need a microphone that has enough switching in it that you can do that. And you have to have a 5-wire mic cord also. So a 4-wire mic cord isn't going to work. Now, that was a pretty common thing back in the day, and what I've actually done to this radio is I've turned it into a relay receive. So inside this radio, there's a relay. When it's not in transmit mode, the relay connects those 2 pins. So I don't need a 5-wire mic on this radio. So that's just a modification I made to this radio. So the older mics that only had 4-pin circuits would be easier to just plug in and work. But most of your older Kerber 142s, or in fact all of them unless they've been modified, are going to have that separate common wire and microphone audio shield. And you'll have to have a mic that has 5 wires and the additional switching inside of it for that function to work. So what I've done, because I still use this CB rig on 10 meters occasionally, so therefore I want the ability to be able to plug in a set microphone, of which I have many. So there's 4 microphones there, and I want the ability to plug 3 of those microphones into both my Yaesu and my old Cobra. Right now, only 2 of them have that capability. So this is the Cobra Dynamic over here, and it has this 5-pin connector on it. So this will work with my Cobra. And then utilizing an adapter that I whipped up that has a 5-pin socket on one end and an RJ45 like the Yaesu on the other end, gives me the ability to use this particular microphone on the Yaesu as well. I have 2 mics that are like that. I have this old Cobra Dynamic right here, and then I also have this Turner +2 microphone that also has a 5-pin connector on the end of it. So both of these microphones I can use with either the Cobra or the Yaesu. Like so. So they're dual purpose mics. I can use them on either radio using the adapter. So today's project is this microphone, which this is another Turner +2, and this is actually my original Turner +2. This microphone is very old. So this project, today's project, is this old Turner +2 here. This is my original Turner +2. This microphone is has been in my possession for about 35 years. And it didn't survive a move that I did. So I had it packed in a box, and somehow in the move it got jarred, and the ceramic element inside of this head failed, and it stopped working. And I threw it in a box, and I just left it alone. And eventually I found a replacement in this one. And these mics are very similar. They're not identical. This microphone has a circuit board in the head. It's the newer version of the Turner. The original version has the circuit board in the neck. But they both sound very similar because the components used on the board are tailored to make them sound very similar. The only difference being that this one here that has the circuit board in the head has a bit more gain than the older style Turner. But unfortunately, that's kind of a common thing with these ceramic microphones, is these elements go bad from vibration or impacts, and they will fail. So what I did in this case is I modified this microphone by putting a dynamic element in it and then changing the input resistor to change the input impedance of the mic. And it works great, and it's actually my favorite microphone now because although I do like the older Plus 2, this has a real low frequency bass response that it's kind of overpowering. And just listening to these two microphones back to back, I actually prefer this one with the dynamic element. Which brings up an interesting point. You might ask yourself, why would you want to put a vintage microphone on one of these radios? There isn't really any gain benefit as far as microphone gain, because most of these newer ham radios have really good front ends, and the microphone gain is adjustable. You can set it wherever you want, and they don't really need an amplified mic per se. But the thing is, most of these amplified desk mics, the circuit boards have components in them that will tailor the frequency response, and that's why these mics sound different. If you have, let's say, a Turner Plus 2 SSB compared to that Cobra Dynamic over there, or a Turner Plus 3B, or a Turner Super Sidekick, compared to, a static D104, and actually the Static Corporation made several different microphones with different elements and different circuit boards, and they all sound different. And it's just because the frequency response of the circuit board by the components that are installed in them are all different. So these Turners, what I like about them is that they tailor the frequency response to accentuate the bass. They kind of suppress the mid-range a little bit, and then they accentuate the highs, which is very good for a very warm-sounding microphone on the air. And a lot of people like them. I'm one of them. On sideband especially, they sound fantastic. On AM, on some radios, they can actually sound a little bit muddy. But on sideband, they're just fantastic. So that's the advantage of using a desk mic. Also, when you're talking on air, you don't have to eat the microphone. You can stand back from it 8-10 inches or so, just let the amplifier do the work. A caveat with that, and one of the downsides of an amplified desk mic, is they will amplify any background noise that you may have. So if there's the TV on in the house or a fan in the room, whether it be just an air-moving fan or fans in a power supply or fans in an amplifier, it will pick that stuff up and it will amplify it right along with your voice. So that's kind of the problem with amplified desk mics. But if you're in a quiet room, they do work well. So I want to be able to set up this microphone, which I just wired an RJ45 connector on to work with my Cobra CV. So what I'm going to have to do is put this 4-pin cable on it that already has, a 4-wire cable that already has the 5-pin connector on it. Now, I already know how it's wired, so that's going to save me some time. But what we have to do next is take this microphone apart and get rid of this RJ45 connection. And once we do that, I'm going to show you how to identify the circuits in this microphone on the Yaesu. So I'll give you the pinout for that in case you're interested, and I'll show you how to identify and isolate the 5-volt circuit so you don't cause any damage to the radio. We're not really worried about the mic. What we want to do is keep from blowing our $1,000 Yaesu up. So And let me pop the screws out of this, and we'll look at what's inside. These are not the correct screws for this. I put these on here to lift it off the desk because the battery that I was using was thicker than a stock 9-volt battery. So as I mentioned, this is the one that has the amplifier in the neck. And you can see that up in the neck there. It just attaches with the screw. And from here we need to start identifying circuits. Now most of the time these microphones have reed switching in them. The reed switching in this one wore out, so I ended up putting micro switches in. And you can hear those. Actually, this reed switch is intact. It's only this side. I put some microphone switches in. Actually, that reed switch is just a spring. So I have 2 double pole, double throw micro switches in here, and that's what accomplishes the switching in this microphone. And it's a good idea when you're doing this just to identify the wires that you can see. For instance, this is our 9-volt wire coming off the battery. And there's a ground wire here that's coming over, and it's attaching to one of these pins so that the 9-volt source isn't connected until you key the mic. And then coming out of this cable cord here, we should have 3 wires. Oh, I'm sorry, 4 wires. So on this Yaesu, the only 4 wires that we're going to deal with are microphone shield or microphone ground, microphone audio, so that's 2 wires, and then push to talk and push to talk ground, which would be common on a CB radio. So I believe this yellow wire is my microphone wire. So the yellow wire coming off the circuit board is the mic audio, and that's going to this white with a blue trace. So, consulting my notes, it looks like mic audio is white-blue, so white with a blue trace. Mic ground is a straight blue wire, this wire here. The push-to-talk wire is green, so this green wire right here is push-to-talk. And then our push-to-talk ground is brown with a white stripe, this one. So now that we know which wires are which, I'm going to go ahead and I'm going to notate on the mic end what color codes I'm dealing with here. So it looks like it's a black wire. So push-to-talk ground is black. Push-to-talk is gray. And mic audio is yellow. And then mic audio ground is blue. Now I can clip these wires and get this out of here. Now ordinarily you would be doing this from the plug-in. You would have a microphone with a cord coming off of it, probably just wires hanging off the end of it like this. And you would wire your connector on the end of it. That's typically how this is done. I'm kind of doing it backwards, but inside of this there's just tabs that correspond with these terminals that you solder to. It's pretty straightforward. And basically the same thing I'm doing. I'm just doing it in reverse. So I got my wires identified. This is kind of important because you only want to do this once, and it's not like you're going to damage the radio if you've already isolated your 5-volt reference and you know where that is and you've cut that out of your connection so that you can't make a mistake. But in this radio, of course, we have 4 wires. We have microphone shield, microphone audio, and then we have neutral and transmit. So neutral or common, PTT, common, and then PTT transmit. So I've written all this down. I know the pinouts to my radio. I've got those written down. I took notes a long time ago. And I also know how they matched up to a standard Cat5 cable. So I wrote down where these color-coded wires go to in this connector. So I know that when you're wiring a mic, you know, a certain color code here is going to go to a certain pin on the microphone. So all of that's written down. It's been verified. If you're doing this from scratch, of course, you're going to probably just go to the internet and try and find a connection pin diagram for your radio that you're going to use. Now, Of course, everything on the internet is true, and there are no mistakes on the internet. Everything you can believe. You're never going to get into trouble by going to somebody's website and blindly trusting what they have there. Not. Always verify, that the reference that you found online is actually the truth. And there's several ways you can do that. Just find more than one reference. If you find 5 or 6 websites agreeing on the pinout to your radio, and then 1 or 2 that are not, probably the 5 or 6 are going to be correct. And then, of course, once you have an idea of what your pinout is going to be, you can just turn the radio on, and whatever that pinout is calling your common and your transmit, just briefly touch this together and make sure the radio transmits. If that part's right, likely the whole thing is going to be right, and you'll be okay. So in my case, I know on this cable, this is a microphone shield. This is a microphone positive, which is the output from the circuit board, the amplifier board. The red wire is transmit, and it should be, that's obvious, right? And then the black is common. And that's going to match up on my microphone as, we'll start with the microphone ground. Shield should go to blue wire. So our shield's going to go to this blue wire down here, which I don't have much sticking out, but we'll work with that. So shield goes to blue. Then the microphone positive goes to yellow. That's the wire coming out of the circuit board. And then we have 2 wires left over. We have a black and a green, which actually goes to the gray on the switch. And the black is going to be our PTT ground, or common wire. And then the green is going to be the PTT, which actually transmits the radio. All right, and we'll see if this works. Plug in my adapter. Let's see which antenna I've got dialed up. And I'm going to plug in the connector. Hopefully it won't transmit. So far, so good. I'm going to turn my mic gain all the way off in the mic, and let's see if it transmits. So I think it might be inside of this plug. This plug may be wired well. Let me check and make sure the radio keys up from here. Which it does. And we'll get this small screwdriver and we'll take those screws out real quick. And these screws are very tiny and they're easy to lose. I usually don't take that last one all the way out. I'll just flip this around like so. And there's another little screw right here. That's usually the one that gets lost right there. It's a very tiny screw. And how is this thing wired? So Well, I can say already it's wired wrong. So my common pin should be here. So the transmit wire is correct. Transmit, but that should be common. So this, oh, I've got it cut back. So I'm going to have to redo this whole thing. So let me get this off and I'll start from scratch and redo this whole connector. Transmit, common, receive, shield, mic. So transmit, common, receive, shield, mic. Okay, so we're all wired up. Now we'll give it a quick test. Just want to see if the radio transmits. Yes, it does. Okay. A little plastic shield shoves over that, and we'll line up our screw hole there. Managed not to lose the small screw. And we're done. So checking for phantom power coming out of the radio. You can see that I've cut a few of these wires back. One of these wires is a 5-volt wire. So let me go ahead and trim this back a little further, and we're going to expose those wires. And then we'll see how we can check this to see which one is 5 volts, so we can stay away from it and maybe not blow up the radio. Just for clarity, I'm going to take these 3 wires that I know what these 3 do. This is push to talk ground, audio, and I believe this green wire here is part of that too. So these 4 wires, I'm just going to whack these off because I want these out of my way. And I'm going to cut them a different length each one so they can't short out against each other. There we go. So those are out of my way. And then these 3 wires here, I'm pretty sure one of these has got 5 volts on it. Now, according to Yaesu, pin 3 is the one that has 5 volts on it. And according to my key, which I wrote down quite a long time ago, pin 3 is a green-white wire. So I'm going to check that one first. It saves time. So the way that I'm going to do this is you need, for your meter probe, you need ground. And then, of course, the red lead is going to go on your wire that you're checking for 5 volts. So I could use the ground lead in the mic connector, which is either pin 4 or pin 7. I'm not sure which. One's a mic ground and one's a PTT ground. But instead of doing that, what I'm going to do is I'm just going to use the case ground on the radio because I don't want to hunt 2 wires. I just want to hunt 1 wire. So we'll go ahead and turn the radio on. So right now there's 5 volts on this wire, supposedly. Now what I'm going to do is just touch a case screw with this ground lead, and then I'm going to go ahead and touch the red lead to this green-white wire. And there we go, 5 volts. So now I know which wire has 5 volts on it. And if you're wiring a vintage mic that doesn't need power, what you're going to do is you're simply going to cut that wire off short. So I'll go ahead and turn this back off. Now I know this is the wire that has 5 volts on it, so I'm going to eliminate it. I'm just going to go ahead and cut it way back here. So that wire can never short against anything and blow the radio up. And that's basically how I do it. So now I have all these wires, basically all the other wires in the radio, you could probably touch to each other. The worst situation that's going to happen is it's going to transmit. But you shouldn't be able to damage anything by doing that. Once we get that 5-volt circuit out of there, we don't have to worry about it anymore. And that's basically how I do it. One more thing we need to talk about is most of these vintage mics will have a switch on the bottom. And that switch is for either electronic switching or relay switching. And what's meant by that is some of the old tube rigs and some of the old radios, instead of combining the shield and the push-to-talk ground, what they did is when you went to relay switching, it would switch circuitry on the pins for the switching inside of the mic, and it would just take, when you key the mic, it would just take 2 pins on the mic cord and just touch them to each other. So it would make continuity on 2 pins in the mic cord. It's similar to what was happening with the 5-pin, except there's no receive circuit. So with relay switching, what the mic was doing was taking probably, in an old tube-type radio, a very high voltage circuit. It could have been 90 volts, 100 volts, 110 volts. And it was just connecting it to an out pin that goes back to the radio in order to make the thing transmit. But it had to be a separate circuit because often it was high voltage. So when you switch it into relay switching, it would make a provision for that high voltage just to go through the mic without affecting any of the other circuits. When you went to electronic switching, what would happen is it would combine the shield and the push-to-talk ground as one circuit. And that's how most of the newer transistor radios are set up. So, excluding the 5-pin Cobra stuff that has a separate push-to-talk ground and a separate microphone shield ground, those are an animal all their own because you need 5 wires because of the receive circuit that's in it. But the typical 4-pin Cobra stuff would combine that shield and push-to-talk ground, and with electronic switching, it would work just fine. Now, the other thing that this switch you may find switches on these radios, sometimes the purpose of the switch is for impedance change. So there was a circuit inside the microphone that would switch from either high impedance to low impedance or vice versa. Typically, most CB and ham stuff is high impedance. You only really find low impedance with audio microphones that are used in the music industry. So something with a XLR connector would be low impedance. But some radios actually use that. So just depending on what you would have, you might have to switch to a low impedance circuit, and then some radios have that, or some microphones have that capability. Most of them do not. Most of them are high impedance, and that's it. One other thing to mention is if you actually look at the circuit schematic for a lot of these microphones that have an amplifier in them, you'll see that by changing the mic gain on the microphone, it actually changes the impedance of the microphone. So I think that's done intentionally so that the microphone will work across a wide range of impedances. So it'll work just fine over a wide range of impedances because there's a bazillion different radios out there and they're all different impedances. Sometimes they're 400 ohms, sometimes they're 800 ohms, 600 ohms. So by changing the impedance with the gain knob, you could make that mic work on an ICOM or Kenwood or Yaesu or Cobra or Uniden or President. Didn't matter what it is. So I think that was done intentionally, but if you stare at that circuit, you can see that. The way the potentiometer is set up, it's obvious it's changing the impedance of the circuit. Now, something important to mention is just because you can wire it to a certain radio doesn't mean it's going to work. I spent quite a bit of time figuring out what the pinout of this Anytone radio was and wired one of my desk mics to it, and it did not work. The audio was super, super weak. So the problem is that inside of this hand mic, there's a circuit board, and it's got some amplification built in, I'm guessing. So like the first stage of the application for this radio is inside the mic, and the output of a regular desk mic just isn't good enough. So just because you can wire it to a radio doesn't mean it's going to work. Okay, to recap, if you're going to wire an unknown mic to an unknown radio, the first step is to make both the microphone and the radio known. So you'll get on the internet, you'll research the pinout for the radio, you'll research the pinout for the mic. Microphone cords and wiring are different colors. Sometimes they'll substitute blue instead of red. You can find any color really. You got to figure out if it's a CB, is it a 5-wire, is it a 4-wire? Do you need a separate PTT ground and a shield ground? Is your microphone capable of doing that? In other words, does it have a 4-wire cord or a 5-wire cord? One of the things that I've seen with these Turner mics is many times this blue cord will be gone. This is the factory cord for a Turner microphone. It's only got 4 wires in it. And you'll see a lot, like the microphone we just got done wiring, it'll have a black cord on it, but that black cord will be a 5-wire cord. And what they've done is they've set it up for one of the newer Cobras, like a Cobra 2000 uses a 5-pin connector, so they could separate the PTT ground and the shield for the audio. So it's possible you run into that. You'll have to know that up front. So in many cases, wiring a microphone isn't as simple as putting a connector on the mic. You have to go inside the mic and rewire the switching to make it work for what you're going to do. Something to be aware of. Sometimes the mic needs to be modified in order for it to do what you want it to do. But as far as the ham stuff goes, typically we're only concerned with 3 connections, perhaps 4. The Yaesu needs 4 because the PTT ground and the audio ground are separate. So PTT, ground, PTT, audio ground, audio, 4 wires. The switching is handled by circuitry in the radio for receive, so you don't have to worry about that. Go on the internet, find the pinouts for your radio that you're going to be working with. For the Yaesu, this is what I come up with. And this is from top to bottom on the connector. So starting at the top of the connector and working down as looking into the radio. So the highest pin on the connector is the down circuit for up and down channels. Number 2 pin down is the up wire. The 3rd one down is 5 volts. That's one we stay away from unless we have an electric condenser mic that needs it. The 4th wire down in the connector is the mic ground. The 5th wire down in the connector is mic audio. Number 6 is push to talk. Number 7 is push to talk ground. And the bottom connection is going to be fast or slow tuning for the VFO. So we don't use pin 8 either. So the only 3 pins, or only 4 pins we're going to use on a Yaesu is pin 4, 5, 6, and 7. And Yaesu knew, evidently, that guys would be wiring mics to these radios because they put them right in a row, 4, 5, 6, 7. So those are the 4 that we're concerned with. Starting from the top, going down. 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7 are the 4 wires that we're concerned with when wiring vintage mics to a Yaesu. And as far as I know, all the Yaesus with the RJ45 are the same. I know the FT891 Mobile is the same as an FT710 base. They are the same. I verified that. So troubleshooting. If you wire the mic and the mic does not key the radio, put a no meter on the 2 pins that you know are the transmit, so PTT and PTT ground on your microphone. Key the mic. Make sure you have continuity with the DVOM set to ohms. If you do, go to the radio and make sure it's wired properly on the radio end. If you don't, go inside the mic and find out why. If you key the microphone and it squeals, if there's a squealing audio, if your ALC meter just slams over and you're not saying anything, check your grounds. Check your shield ground. Typically, most microphones will have the ground side of the power circuit grounded to the housing of the microphone. Make sure that's there. Make sure the shield ground is intact on the audio circuit. Usually that's what it is. If there's a break in that circuit at all, the microphone will squeal. If you're working with a CB and it transmits fine but it won't receive, you're going to do the same thing that we did with the DVOM on the transmit side, but you're not going to key the mic. So typically on a CB radio, when you let off the microphone key, there's a normally closed switching in the mic that connects 2 pins on the mic cable, which would be your common lead and your receive pin to make the radio receive when you're not keying the mic. So you would take a DVOM and go across those 2 pins with the mic unkeyed and make sure that there's continuity with the mic unkeyed. If you key the microphone and there's feedback through the speaker of the CB, it means the receive side isn't breaking. It's not opening up when you key the mic. So you're going to go into the mic and you're going to find out why. Is the switching not synchronized correctly so that when you key it, typically what happens is the receive circuit opens up before the transmit circuit engages. So sometimes you have to bend those reed pins inside the mic to make sure that they're sequenced correctly. As you key the mic, the receive should break first, and then the transmit makes. If that doesn't happen, you'll have little squeals and pops as you key the mic. If the receive never breaks, it'll feed back through the speaker in the radio. Obvious at that point, and you just go on the mic and find out why it's not opening up that circuit. So I think that basically covers it. I hope I covered everything. Wiring mics can be tricky, especially when you're working with a ham radio that can have 12 pins. Some of these ham radios have 12 pins in the mic connector. That gets confusing, but typically you're only dealing with 4. We only have to deal with 4 pins. So you just got to figure out which 4 pins you're working with and ignore the rest. These old microphones can be found in Hamfest. They can be found on Facebook Marketplace. They can be found on Craigslist. The ceramic elements in these mics do go bad. So I wouldn't pay too much for an old vintage mic unless the person selling it to me showed me that it worked. If it's a $10 microphone, it doesn't really matter. You can buy it and take your chances. As with this mic, some of them can be swapped out. You can take the ceramic element out and put a dynamic element in or something else. I actually like the sound of this. In fact, maybe to cap this video, maybe I should do an SDR audio grab of the original Turner with the ceramic element and this microphone with a dynamic element, so we can hear the difference, because it's quite pleasing. I really like it. Okay, so the way that I'm going to do this is I got both mics here, and they're side by side, and I'm going to start with my original bone stock standard ceramic element Turner Plus 2 SSB, and I'm going to record audio using Kiwi SWR, and the SWR that I'm going to be recording is over in California. I'm going to do this on 40 meters. So I found a quiet spot in the band, and I've got this Kiwi SWR set up at 7.235 megahertz, and it's lower side band. I've got the bandwidth set at about 3,300 kilohertz, I believe. 3360. So we can get all the bass tones, we can hear that and record it. And Kiwi SWR is neat, and it has a feature over here that you can record. And you can also mute, but you don't want to mute it, because if you mute it, you won't be able to record anything. So I've got the speakers on the computer muted, so it won't feed back into the radio when I transmit. So now what I'm going to do is I'm just going to hit the record button on the Kiwi SWR. Then I'm going to transmit on the radio. I'm going to transmit some audio. Just hot swap the mic, transmit some more audio, and then we'll listen to the result. So, recording, and here we go. Testing 1 2 3, testing 1 2 3, checking audio mic 1. Testing 1 2 3, testing 1 2 3, checking audio mic 2. Alpha India 7 Victor Victor. I'm going to stop the recording, and it saves it to the computer. And now we'll go and we will listen to that. So the first thing I have to do is unmute, so now I can hear the audio. And we'll mute the SWR, or SDR. So the SDR is muted. And let's listen to our file.
Testing 1 2 3, testing 1 2 3, checking audio mic 1. Testing 1 2 3, testing 1 2 3, checking audio mic 2. Alpha India 7 Victor Victor.
And that's what they sound like. And like I said, the original Turner with the ceramic element is quite basic. I like it. But the other microphone is very similar in the tonal qualities, just doesn't have quite as much bass. So I prefer using that one on a day-to-day basis. So, all right, so much for Mic 101. Thanks for watching.